I have always been intrigued by the idea of flight. The thought of being able to lift off from the ground and soar through the air to view the world from a different perspective just excites me. And when I discovered FPV drones, I just knew I had to experience it for myself. So I decided to build one, in the hopes that my dream of being able to fly would become a reality. But first, what is an FPV drone? First-person view drones or FPV drones are different from the typical camera drones most are familiar with. FPV drones are more powerful drones that are usually used for freestyle flying or racing, but they can also be used for cinematic footage. The main difference that FPV drones have over regular camera drones is that they are flown in full manual mode or acro mode, without any stabilization or assists, allowing the drone to execute maneuvers that wouldn't be possible with regular camera drones. FPV drones give the pilot a unique experience as it allows a person to fly as if he or she is in the drone. Now that we are familiar with what an FPV drone is, let's build one. I will be building what's known as an analog freestyle FPV drone. Analog is the video system and freestyle is a type of flying that involves doing flips and tricks with the drone. The main reason for going analog is really the price, since it's much cheaper than digital video systems. Here we have the frame, which is basically the skeleton of the drone, and this is where all the components would be attached to. This is a 3.5-inch frame. 3.5 inches means that the frame is made to be fitted with propellers with a 3.5-inch diameter. The frame is pretty simple to put together. You start off by attaching the arms to the aluminum plate and then screw that onto the bottom plate. The frame has mounting holes for both 20 by 20 and 30 by 30 stacks. In my case, I will be using a 30 by 30 stack, so I'll be screwing the stack screws into the outer press nuts. Now it's time to install the motors. Since I will be running this build on 4S, I went with the HG LRC Aeolus 2004 3000 kV brushless motors. Now let's move on to the flight stack. The stack is made up of the flight controller or FC and electronic speed controller or ESC stacked on top of each other. For this build, I will be using the T-Motor Velux F411 light stack. If you would be building on this frame, I do recommend using a 20 by 20 stack since the build would be a bit tight with 30 by 30 electronics. The ESC that came with the Velux F411 Lite was actually too long for the frame, so I had to mount it sideways, which wasn't ideal as part of the ESC would be sticking out. I really should have done more research before buying the parts, but since we're already here, I just have to make it work. You would also need to purchase M2 nuts since the nuts that came with the stack are M3 sized nuts. Now it's time to place the ESC onto the frame. I bought some of these M2 O-rings to use as spacers so the ESC does not come into contact with the bottom plate. Here I'm taping the motor wires to the arms just to tidy things up. After taping the wires, I cut them to length and strip the ends before soldering them onto the ESC. Okay, so I've managed to solder the motor wires and XT30 battery lead onto the ESC, and I've also soldered on some leftover motor wires to the bottom battery pads and routed them just below the ESC to this capacitor. and I will just be soldering the wires onto the capacitor. Later, I will wrap this capacitor with electrical tape and stick it onto the frame with double-sided tape. Let's go, it powers on. We are far from finished though, so let's carry on with the build. We will now work on the flight controller, or FC. So the flight controller is essentially the brain of the drone. It allows the drone to move or fly based on the pilot's inputs together with the information from the components connected to it. So I will just tin the pads where the camera, VTX, and receiver would be soldered onto. Another important component of the FPV drone is the VTX, or video transmitter. This takes the video from the camera and transmits it to be received by the goggles. I will be using the Rush Tank Ultimate Mini VTX. This VTX has wires included in the package, and I will be soldering them onto the ground, DC in, smart audio, and video pads. Then I soldered the VTX wires to the appropriate pads on the flight controller. With the VTX connected to the flight controller, I can now mount them onto the drone. Here I just plug the connector connecting the ESC and flight controller. Then I can slide the flight controller onto the stack screws. I also twisted the wires to get rid of the slack. I would also like to point out that I bought M2 rubber grommets for the flight controller so that it sits better on the stack, since the stack screws are M2 sized. The VTX mounts onto the rear using the included M2 screws and nuts. I opted to use just 2 screws to save some weight. I used 4 M2 nuts to secure the stack, as you can see here. The next component I will be installing is the camera. This is the Runcam Phoenix 2 SE. The camera will be screwed onto the 2 aluminum plates, and before it gets mounted onto the frame, I cut the wires to length. With the wire shortened, I can now mount the camera assembly onto the frame. I can now solder on the camera wires to the flight controller. This is very finicky soldering, and I have to make sure that I don't get any solder bridges. After soldering, I detached the camera so I can twist the wires to remove the slack. I kept the camera screws loose for now since the aluminum cage has to move a bit to align the screw holes for the top plate, which will be attached later. Next, I will attach the VTX antenna. I did a little modification to the plastic stem of the antenna where I cut off some of the plastic so that the wires won't bend too much when I install it. The antenna goes into this red plastic piece, and that screws onto the 3D printed piece that comes with the frame. With the antenna attached to the TPU piece, I can now connect it to the VTX. Now I can screw the rear standoffs together with the rear TPU piece onto the frame. The next component is the receiver. This is the Happy Model EP1 Express LRS receiver. As you can see, this thing is incredibly tiny, and I've already soldered on the wires. I just need to put on the heat shrink. With the heat shrink on, I can now attach it onto the frame. All that's left is to solder the receiver wires to the flight controller, and we can attach the top plate. But before we close this, let's see if everything works and I didn't mess anything up. Make sure you use a smoke stopper when you first power on your build and that the VTX antenna is connected. Okay, let's try to plug in the battery, I guess. And it works! I was so thrilled when I heard those beeps, and I was just glad that I didn't smoke anything up. But that excitement quickly died out, as I now had to configure the flight controller. You see, the flight controller runs on the Betaflight firmware, and before we can fly the drone, you have to set up the firmware. I have no experience with Betaflight, and there's a lot to learn with this software. Thankfully, there are several guides and tutorials online, and I was able to follow them and set up my drone. The only real hiccup was setting up Express LRS. The ELRS receiver and ELRS module on my radio both had to be flashed with the latest firmware before I can bind them. When I flashed the receiver, I kept getting errors. I even thought my wiring was wrong, so I tried to change the wiring, but I ended up soldering them back to how they were the first time I soldered them. It turns out, the receiver was just not getting any power, which is why I wasn't able to flash it. I just needed to plug the battery, and then I was able to successfully flash the receiver. But my battle with ELRS did not end there, since I also had to flash my radio with the latest ELRS firmware. And this did not go smoothly. I think I even broke my radio trying to flash it. This issue is actually common with Jumper T Pros, but thankfully there was a fix, but it involved having to take apart the radio and soldering on a wire. Pretty annoying, but in the end, I got everything to work. With the setup done, I can finally finish up the build. Here is the completed drone. I'm actually very pleased with how this thing turned out. Other than the ESC sticking out of the frame and the bricked radio, I would say this build went quite well. It was definitely a fun and interesting experience. Now let's go fly it. I gotta say, I'm hooked. FPV drones are just awesome. I really enjoyed the journey of building the drone and learning how to fly it. Flying the drone was such a unique and exciting experience, and I will definitely keep on practicing to improve my skills. I hope you guys enjoyed this video. Thank you so much for watching, and I'll see you in the next one.